Good day, grade 10s. I would like to discuss the concept of interference with you. You will need to go to your physics textbook. The section is on page 13 to 17. First of all, I want us to discuss the principle of superposition. What is superposition? Superposition is the phenomenon, the occurrence, what you see when two or more pulses or waves moving through the same point in a medium at the same time forms a different disturbance, pulse or wave, with an amplitude that equals the sum of the different amplitudes. The principle of superposition is that when two or more disturbances occupies the same space, so they're in the same place, at the same time, they form a resultant disturbance that is the vector sum of the two disturbances. Now, we refer to vector sum here because if you have a transverse pulse, that broken line is representing the rest position of the medium, and the pulse displaces the medium to make a crest. That is called a crest with a positive amplitude. And when another crest comes along with a positive amplitude, the vector sum is positive plus positive, which makes a bigger positive. But if another pulse comes along with a negative amplitude, it would be displacing the medium to the opposite side of the rest position. So like we discussed with vectors, this pulse would have a negative amplitude. So a trough we can take has a negative amplitude, where a crest is a positive amplitude. So you're adding opposite direction things. So that's why it's called the vector sum. Now, very interesting is that interference is called a wave phenomenon. It means that only waves can coincide to be in the same space at the same time. So, the interference is said to be proof of wave nature. So we know that light has wave nature because of interference patterns that we observe when we look at light, or diffraction patterns as well. But that we will discuss in grade 11. So there are two types of interference. The one is called constructive interference and the other one destructive interference. So what is constructive interference? It occurs when two pulses or waves meet to form a resultant bigger pulse. Both will have a positive amplitude or both will have a negative amplitude. They strengthen each other or cause a disturbance with a bigger amplitude. Then after superpositioning, pulses move unchanged. Destructive interference occurs when two pulses meet to form a resultant smaller pulse. So one would be a positive and the other would have a negative amplitude. So we say that they weaken each other or they could cancel each other out. There will be a smaller or a zero amplitude. And after the superpositioning, the pulses will move unchanged. So I want us to discuss constructive interference first, and I want to use the example on page 13 in your textbook. The example that they have there for constructive interference has a pulse. A pulse is a single disturbance with an amplitude of 10. So this amplitude is plus 10. We don't know whether it's centimeters or millimeters, so we have pulse X moving to the right in the medium, and in that same medium there is a pulse Y coming towards it with an amplitude of 8. So pulse Y has an amplitude of plus 8, and we can call this pulse Y, and it's moving in the same medium towards X. Now, to illustrate the interference, this is where the pulses are before interference. Now, they are moving towards each other, so there would be a point where X and Y are in the same space. This is now X and Y superposition. And the amplitude will be the vector sum. We say this is the resultant amplitude. We can use a little r to represent resultant, or res for resultant. Would be the vector sum. So plus 10 plus 8 will be plus 18. Now, in a test or exam, you may be required to actually physically use your ruler and measure the pulse width as well as the amplitudes. So we would take the pulse width of all of the X and Y as the same, so the superimposed or superpositioned pulse width would be the same. So this is at the moment when the pulses are interfering. They don't stop while they're there, they carry on moving. So pulse Y was busy moving to the left, and pulse X was busy moving to the right. So pulse X will now be here, and pulse Y will be there. They remain unchanged. Now, maybe my diagram isn't as accurate, but this amplitude will still be plus 8, and this pulse's amplitude will still be plus 10. Nothing is changed. It's just at that moment of superpositioning, the resultant disturbance is more than what it is for the individual pulses. I'm going to stop the video here, and then I'll make another one for destructive interference.